Good day, students. I am Taylor S.Adebayo, and I will be taking mathematics, and the topic here today is statistics. We are going to be talking about the computation of mean, mode, and median for both grouped and ungrouped data. We also compare mean, mode, and median. Thereafter, we'll talk about rates and mixtures. Before now, in our JSS class, we were familiar with solving little problems of statistics, and we were told that statistics mainly deals with the collection, analysis, and presentation of data. So when we have cumbersome data, when we have some set of data and we need to try to present them in a meaningful form, what you do is to collect samples, collect the data, then we analyze the data, and thereafter we give an output, which is to present data in a meaningful form. Basically, in this course of study, we shall be discussing mainly the mean, mode, and median. I want to let you know something here, that in statistics, there are two classifications of the tool that we use to measure our statistical data. The first one is the measurement of central tendency, while the second one is the measurement of dispersion. The measurement of central tendency is also called measures of location, and examples of such is the mean, mode, and median. They are all called measurement of central tendency or location, or measure of location. While the measure of disperser is the range, standard deviation, variance, and the likes. This shall be discussed in some other days, maybe S.Adebayo. So we need to intimate ourselves that there are basic three tools that we use to measure data under the measurement of central tendencies, which is the mean, mode, and median. Practically, what does it mean? The mean, what does it depict? The mean is an average. The mean is an average. When we say average means summation or addition of any set of data or data given to us divided by the numbers of the data. So a mean is more or less calculating an average. When you say if we have 10 data, for instance, and the question asks us to find the mean is summing all the 10 data together and divide them by 10. If there are 25 data that we need to analyze, the mean is to add each of the data together and divide it by 25. Second one, which is the median. I call the median the middleman, the middle number. The median is the middle number after you must have arranged any set of data given to you in either ascending or descending order. When one arranges the data given to us in maybe from the lowest to the highest, that is ascending, or from the highest back to the lowest, that is descending, the number that falls in the center, in the middle of the arrangement, is then the median. Don't forget, you must arrange the data whether ascending or descending before you can pick the median. The last one here, which is the mode, is the number that occurs frequently, or the number that occurs most frequent, the number that have the highest frequency, the number or a particular object that has a kind of repetition more than any other object. So whenever we are asked to find the mode is just the numbers that occur most in the set of data given to us. Quickly, let's talk about arithmetic mean. Arithmetic mean is the sum of all ungrouped data divided by the number of the group. I told you that when you sum any set of data, excuse me, and you divide it by the numbers of the data, what you have found is the average or the mean. Excuse me. So look at the first formula on this PowerPoint slide. You can see the mean x bar. That is one thing I want you to note. A mean is represented by x bar. We have a bar on x. Is the summation of x over n. That is when we are dealing with small set of data, we use this formula. When you are dealing with small set of data, we just sum them together and we divide it by the numbers of the data. And I said summation x means sigma. The sign of that like that looks like the E is sigma, but it's pronounced as summation. And it means the sum of whatever things you have in the front. So whenever we have a large number of data to analyze, the mean becomes the product of the scores or the product of the frequency and the x divided by the product of the sum of the frequencies. That is summation fx over summation f. We're going to discuss the use of this tool in our next slide. The first example, we want to get the arithmetic mean of the 42, 50, 59, 38, 41, 86, and 56. When we want to get the arithmetic mean, I told you, when we have small numbers, we just add them together and divide it by the n. And in this particular example, you can see that each of the data has been added together and we divide it by the numbers of data. And that gives us 54 as the mean. In the second table, which is an example, this is actually a Y question. The table below gives the frequency distribution. This is actually the one that is as frequency that is more. We have the data here is more. The question says we should collect to 3 significant figures the mean mark of the distribution. This is actually the marks obtained by some students in a scholarship examination. So scores and frequency. If you look at this table, you see that the first table on top, 15, those people that score 15 is 1. The number of students that score 25 are 4. The number of students that score 35 are 12. The number of students that score 45 are 24. The number of students that score 55 are 18. 65 are 8 and 75 are 3. So the question says we should find the mean. So what you do is that you create another table. Look at the table I have there, which is the score. First one, the score, the frequency, and the third one is the fx. That is the frequency by the score. And if you look at this expression, you will see that the last column is the multiplication of the first two. The last column is the multiplication of the first two. 15 by 1, 15, 25 by 4, 100, 35 by 12, 420. You can see that. So at the end of the day, under the table, the last column is the addition. With the first one, you add the frequencies together and you add the fx together. Fx column, when we added it together, it gave us 3,350. And when we added the frequency together, we have 70. And that is the reason why you are seeing the mean there to be summation of fx over summation of f, which is the addition of all the fx column over the addition of f's. And we have that to be 3,350 over 70. And when you press that one with your calculator, you get 47.857143. But the question actually says we should correct to 3 significant figures. And that's why we have it to correct to 3 significant figures to be 47.9. A typical example is what we have here as well. That is another table in which the mean is being given. In this example, the mean is being given, but one of the scores or frequency is omitted. Don't forget, frequency tells us how many times that particular number appears. Scores is 1. Those people that score 1, 2, 3, 4, 5 is like a quiz. Maybe that quiz is conducted over 10 by a teacher. 10. So we have 1 to 6. The number of students that score 1 is 1. That score 2 is 4. That score 3 is 5. That score 4, you can see it's not that clear anyway. Number of students that score 4 is X. It is X that you have there. Number of students that score 5 is 2. That score 6 is 2. So they say if the mean score is 3.5, calculate the value of X, which is the number of students that score 4. So the next thing is also to create a kind of column, a table. Another table that shows our first one scores on top, which is 1 to 3 to 1 to 6. If you cannot see very well, that's why I'm trying to at least call out each of them. The score is the first column on top, which is from 1 to 6 down. The second one is the frequency, and the frequency comprises of 1, 4, 5, X, 2, 2. That thing you cannot see is X, 2, 2. And the last column is the summation of the product of fx, like I told you, product fx, and that will be the first two columns multiply each other, giving you the third column. So when we have 1 times 1 give us 1, 2 times 4 give us 8, 3 times 5 give us 15, 4 times x give us x, 4x rather, 5 times 2 give us 10, 6 times 2 give us 12. So now the summation, you can see now the summation the summation of f now, it will be in terms of x, and that's what we get to be 14 plus x. And the summation of the product of f and x is 46 plus 4x. So we now say that the mean in the formula, the mean equals to the summation of fx over summation of f. Summation of fx has been from the table is 46.4x over summation of f is 14 plus 4. And when we now solve for x in this equation, you can see the way I solved it, we are going to get our x to be 6. When you cross multiply, then solve for x, our x is then equals to 6. You can also write this down in your book and try to practice them. Make the table, make the first table, make the second table yourself, and see and confirm the answer. You can also get back to me in case there's any difficulty in getting the answer in any of these questions. Let's quickly talk about the median. The median, I said, is the middle number or middleman. When the items must have been arranged in order of magnitude, either in ascending or descending order. So let's look at the example. Find the median of the following set of numbers: 16, 13, 10, 23, 36, 9, 8, 48, and 24. You arrange in either ascending or descending order first, and you can see that the least data there is 8 to 9 to 10, 13, 16, 23, 24, 36, and 48. If you look around, there are 9 sets of data. Are there 9? 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 of them. So if we want to look at which number is at the middle, that means we have 4 to the left, 4 to the right. By the time we have 4 to the left, 4 to the right, we have a number at the center, which will be 16. So the median of this is 16, as we have 4 to the left, 4 to the right. Now, whenever we now have numbers that have more, or we have very large data, when our n is extremely large, the median, we use these two sets of formulas to find the median. Remember the example one I did above on that median, the n is very small, so easily we can do the arrangement. But at times when the numbers, for instance, let's say we have about 100 data, it is very difficult for you to arrange 100. It's very cumbersome and stressful for you in the exam to arrange 100. So that's why a formula is carved out to solve this. So whenever the numbers of data given to you to analyze is odd, then median is the number of that data plus 1 over 2, the term that falls on that. And if the n is even, the median is n over 2 plus n over 2 plus 1. That is when the number of the terms or the number of data given is even. I will explain how this formula are being used in the next slide. Now, the first one, look at it. I want to use these examples to explain. The first one, the table below shows the distribution of mark scores by some students in a math test. And those people that score 22, we have 11 that score 22. We have 24 that score 2. We have 36 that score 7. We have 42, 13, 45, 10, 48, 3, 56, 9, 65. And to find the median, if we have to first get the cumulative frequency. I want to tell us here that mostly when we find median of any given set of data, we always create the column that we call cumulative frequency table. And how is that constructed? The first column is the max, which is the score in percentage, and the second one is the frequency. The third one now is the cumulative frequency. In the mean, we get the fx, the summation of fx. That is exactly what we need in the mean. But here, we need the cumulative frequency. Now, how do we do that cumulative frequency? Look at the first line, 2211. We repeat that frequency. The first frequency we are going to get under the cumulative frequency, the first number is repetition of the frequency. In the second line, we have 2. So that means as at 24, we have the frequency of 24 to be 2, and the one above it is 11. So under the cumulative frequency, we now add the 2. We are going to add 2 and 11 to have 13 in front of 2. That means as at that column, how many students? As at that column of 24 marks, we have 2 and 11 students on top of it. As at that column of 36, which is the next one, we have 7, 2, and 11. When we add the 3 together, it gives us 20. That's why we have 20 in front of 7. As at the column of 42, we have 13, 7. I'm going from that column up. 13, 7, 2, 11. And that gives us 33 when we add it together. The same thing until when we get to 60. When we get to 60, we see that the column of 60 is 5, 9, 3, 10. That is from that 60 upward. When we add all the numbers together, it gives us 60. And that actually gives us, because one of the things about this cumulative frequency is that the cumulative frequency gives us at the last line, give us the numbers of data. If you count the numbers of data in this question, you see that it is 60. And the last column of the cumulative frequency must be equal to the numbers of data if you want to check yourself that you are right. Now, since the numbers of data is now 60, which is the last line of cumulative frequency, we then conclude that it falls under this formula. This is the formula. Look at the median. When n is even, the last one here, you can see the formula there. That is 60 is even. So we're going to apply that formula, which says that n over 2 th, that is the n over 2 term, the term that falls on n over 2, which is 38 times, plus n over 2 plus 1, the term that falls there. Now the n is 60 now. So when we put that in, we have 60 over 2 plus 60 over 2 plus 1. And we have the 38th and the 31st term. You can see that's the meaning of the th you are seeing there. That is the 38th term plus the 31st term. Now, when we now look at this arrangement, the frequency tables, we see from 0 or from 1 to 60, what number falls on the 38th and what number falls on the 31st. Let's add the frequency. By the time you add the frequency, we can see in the cumulative frequency we have around 42. That's when we have 33 and the likes. Now, so you can see, when you count from the beginning, 11 plus 2 plus 7 plus 30, you see that 30 and 31st number falls on the mark of 42. 30 and 31st number falls on the mark of 42. And that's why we now have the 30th member is 42%, and the 31st member is 42%. So the median is now 42 plus 42 divided by 2. Please, there's a kind of omission on that slide. The last line is median equals to 42 plus 42 over 2, everything over 2. And the next one is 84 over 2. Please let us know that 84 over 2, which is 42%. I think there's an omission when importing the slide to the screen for the recording. So the median in that case is now 42%. That's the number that will be at the center. Another example here, and this one talks about when we have n to be odd. Look at this table given to us. It measures the age of some set of people. Age 10, there are 7 that have age 10, there are 12 that have age 15, there are 13 that has age 11, there are 14 that has age 7, there are 16 that has age 12, there are 17 that has age 9, there are 18 that has age 4, there are 19 that has age 6. So when we calculate the cumulative frequency, we have 7, 22. You can see how I have explained how we get that 15 plus 7 under the 12. 15 plus 7 gives us 22. That's why you have 22 in front of that. Under the 13 mark, we have 11, 15, and 7. And that would 3 added together give us 33. That's why you have 33. And that's how you got to the last one, which is 71. So 71 is the last number under the cumulative frequency table. And that, by fact, is the n. So our n is 71, which is odd. Then we now go to use the first formula that is, which is when n is odd, our formula of median becomes n plus 1 over 2 term. So which is 71 plus 1 over 2, which is 72 over 2, which is 36th member. Our median now is not 36. It is the 36th member of that group. The 36th member of that group. So when we look at the table, we look at under the frequency, where we 36 for. The first one we have 70, the second one we have 15. When we add the two together, it gives you 22. 22 plus 11, that will give us 33. So that means 33 plus 7, we have that one to be 4. So that means the 36th member will 4 because 33 member, the 33rd member is under 13. That's when 30 stops. So the 35th, 36th, that's all the 36 member falls under 14, which has the frequency of 7. So that's why we then say the 36 member is 14 years, and that the median is 14 years. The median is 14 years. And the cumulative frequency can also help us in getting that anyway. So the next one is mode for any on group data. We are going to be talking about the group data and the complex situations in our next class anyway. The mode here for any given data is the example is what we have when we have a kind of case that is not much. And when we look at that, we have 10, 10, and the likes, and the second question says we should find the modal mark in the example. So we now look at the kind of arranging this, because as it appears now, we don't know which is which. So we have to make it a kind of frequency table. We start from the least mark. The least mark is 5 there. How many times does 5 appear? 3. 9 is the next one. How many times does 9 appear? That is 4. 10 is the next one. How many times does it appear? That is 5. Until when we get to the last one, which is 25. So by the time you look at the frequency table, you can see that 10 appears mostly. It's the one that has the most frequency data, which is 5. So thereafter, we can say the mode is 10, because 10 mark is the one that have the frequency of 5, which appears mainly. That's why mostly it has the highest frequency in that distribution. Example of another mode question that is more complex than the former one is this table. And look at the expression given to us, the data and the cumulative, the marks and the frequency table is being consulted on the column you see there. So the first thing you do is that when you are given, this is the mark or class of 30 students, and the question says this is the test marks, the score for 30 students. So you create a kind of frequency table for it so that you know how many times each of these mark appears. 4 is the least, and it appears 4 times. 6 is the next, appears 4 times. 8 is the next, appears 3 times, and like that. So when you look at that, you can see that the one that has the highest frequency is of 7. That is the 7 is 14. So we can say the mode is 14. This is a class activity that I want you to try to work upon. Find the mode of the following distribution. The first one, the age 13, 14, 15, 16, 17, 18, and their frequencies. The question is to find the mode. And the second question says you should find the out of the following set of expression, which one is not measurement of centeredness? I explained before. measurement of center tendency, and measurement of dispersal. The third one talks about the table at the right. Read the questions and solve. And don't forget, under these five, the frequency is a K, according to the question. K. That frequency of number of people of 5 that you cannot see very well is K. That will be there. The question says we should find K. I think when we are importing the mathematics tool to this slide, some functions are missing, and we'll correct that in our next class. I hope you have been able to learn one or two things during the course of this class. In our next class, we shall be discussing more complex cases on the mean, mode, and median, when we have some group data that are more complex than the one we have done. I will be sending some questions possibly to you along the week, and at the same time, we shall be having a mini class quiz on these topics that we just discussed with you during the weekend, whether Friday or Saturday. I want you to also subscribe to this channel so that anytime any video is being dropped in this channel, you will be notified. Thank you very much for your attention. Stay safe. Thank you very much, and God bless.